AI/ML model, deep neural network, DNN, architecture. Pradeep K. Suri, author, researcher, and AI/ML architect. This deep neural network, DNN, architecture shown in your image is designed for patient healthcare risk prediction, a vital application in hospital management systems, HMS. Here's an explanation of the architecture and its relevance from both hospital management and patient perspective. Purpose of the DNN model: to predict a patient's health risk level based on several clinical and demographic inputs. Hospital management point of view: 1. Efficient patient triage. Use case: emergency or outpatient departments can use this model to automatically categorize incoming patients by risk levels, example low, moderate, high. Impact: helps prioritize treatment and allocate resources like ICU beds or specialist consultations. 2. Preventive care and early intervention. By continuously monitoring inputs, age, glucose, blood pressure, etc., hospitals can identify at-risk patients and intervene before emergencies occur. 3. Resource planning. Staffing and medication. The risk predictions help estimate the demand for medical staff, ICU care, medications, etc. Cost management. Helps reduce unnecessary tests or hospital admissions. Patient point of view. 1. Personalized risk monitoring. Patients receive regular updates on their risk score, which motivates them to adhere to medications, exercise, and diet plans. 2. Remote monitoring. Integration with wearable devices or mobile health apps can feed data into this model to remotely assess health status. 3. Faster and focused care. Patients at higher risk are fast-tracked through diagnostics and treatment, reducing complications. DNN architecture breakdown. Layer description. Input layer 5 features: glucose, cholesterol, blood pressure, gender, and age. Hidden layer 1 6 nodes, learns intermediate patterns among all input features. Hidden layer 2 6 nodes, extracts higher level features from the previous layer. Output layer 1 node, predicts risk level, example as a class or probability score. Activation functions, usually ReLU in hidden layers, and sigmoid/softmax in output. Optimization, typically uses ATOM or RMSPROP optimizers. Loss function, binary cross-entropy or categorical cross-entropy based on the output type. Dark mode and visual clarity. Dark mode UI is especially suited for night shifts or control rooms in hospitals. Color-coded nodes, input equals green, output equals orange, improve readability for medical staff and AI engineers alike. Thank you.